Guys, so today we're going to talk about annuity. So annuity is actually an application of series that we're going to see. What is an annuity? So an annuity is an account where you make deposits at regular intervals over a fixed period of time. So maybe, for example, I have $50 and I'm depositing $50 every single month into a savings account. And I want to know how much that savings account will be worth in 30 years, given that it has some fixed interest rate. So a savings account, for example, could be an example of an annuity. Other examples of annuity could be, so we had that savings account. Another example of an annuity could be a mortgage payment, where again, I'm putting a specific amount of money in and paying a specific amount of interest on that money. The money goes in at fixed intervals and it's gonna last for a fixed period of time. Maybe I have a 35-year mortgage. Car payments as well would be another example of an annuity. So what we're gonna do is try to understand when I am making these fixed payments and they're receiving or I'm paying interest that is compounded a specific number of times per year, how much will the annuity be worth after a specific number of years or after a fixed period of time? So to understand this, we're first going to try to think of this in the abstract, and then we're going to use that abstract to come up with a formula to help us understand in a more concrete way what's going on. So the first thing is, here we have a deposit P dollars is made M times a year for T years, and it receives I% interest compounded M times a year. So we're going to first use this to come up with some variables. So the first thing we have here is that P dollars. So that's the fixed deposit amount that I'm making, and I'm doing it M times a year. So maybe I'm going to deposit once a year, maybe I'm going to deposit once a week actually. But in any case, I'm doing it at a fixed intervals. Then the next thing that we have is T years. So we have our first variable is P is equal to the amount deposited in dollars. The second variable that I have here, I, that's my annual interest rate. So that was the next variable we came up with up here. And that's going to be in decimal form. I'm specifying that because that's just going to help us a little bit later on to make sure we're thinking about things in the right way. The next variable we have is M. So M is the number of times that it's compounded per year, that interest, but note that it's also the number of times I'm depositing per year. So the compoundings and the deposits are happening at the same intervals. And then I have T, which is the number of years in total. Now I've come up with this last variable that didn't actually show up there, and that is N. So N is equal to MT will be the number of times that interest is compounded for the duration. So if I'm compounding interest 2 times a year, and I want to do this thing for 30 years, then my N would be 60. That would mean that I'm depositing 60 times and the interest is compounded 60 times. Okay, so then the next thing that's going to be important here is we have this thing called our annuity formula. So our annuity formula is basically telling me how much is my money worth after MT compoundings. So how much is that P dollars that you deposited worth after MT compoundings? So basically, I know that I'm earning interest on it. Let's say that my interest rate is 5%. So then I know that I'm going to earn that 5% over the course of a year. So I'm not just going to get 5% at once. I'm going to be like, first I have P, and let's say I'm compounding 2 times a year. Then I'll have times 1 plus 0.5 over 2. And that'll be the first time it's compounded. And then the second time that will happen again. And that way I'll get that 5% over the course of the year. So that's what this thing is telling me. It's saying, take the P and multiply it by 1 plus whatever interest it's earning there. And then put that to the power of however many times you're compounding it. That's going to give you how much that money is worth after MT compoundings. All right, let's take a second now and make this a little bit more concrete, because with a concrete example, we're going to be more easily able to come up with a formula to calculate how much this is going to be worth at the end. Okay, so we have a deposit of $50 is made every month for 2 years into a savings account that pays 6% interest compounded monthly. What will be the balance in the account at the end of 2 years? So the first thing that I'm going to do with this problem is I'm going to find all of my variables up there, P, I, M, T, and N, from the problem that we have here. So P is the amount deposited in dollars. So how much am I depositing? I am depositing $50. So my P is equal to $50. Actually, let's do this in another color. So my P is equal to $50. The next thing is, what interest rate is it receiving? It's receiving a 6% interest rate. So remember we said that I is going to be in terms of a decimal. So that's going to be 0.06, not just 6. Now, the next variable that we have up there is M. And M, we said, is the number of times interest is compounded per year, or the number of times that I'm investing, that I'm reinvesting my money. So this is compounded monthly. There are 12 months in a year, which means that my M is 12 for the 12 months in a year. My T, I am doing this for 2 years, so my T is 2. And my N is therefore equal to 24. Okay, so now let's think about what's happening. Let's look at this number line that I've written here. This present value, that's where I start. So there, this, we're gonna think of this as right now, and I'm depositing P dollars. Now, one thing that we're gonna assume, that we can't always assume, you're gonna have to think about this sometimes. Sometimes your money is going to be, you're not gonna earn interest for this first period, and sometimes you will. So we're going to be making the assumption that we are earning interest for the first period. Oops. So assume that we will earn interest for the first period. Okay, so what that means is that this money that I've just deposited right here, this P dollars, which is actually $50, so this $50 right here, every single one of these ticks represents two things. It represents a time that I'm going to be reinvesting my money, plus a time that I'm going to be compounding interest. So when I look at this thing, there are going to be 24 of these ticks right here. So we're going to be like 1, 2, 3, 24 times. So how much is the first $50 worth at the end of this 2 years? And the answer to this question is going to be, I'm going to call it A to start, and we'll change that in just a second. So we're going to say A is equal to P times the amount of interest that I'm earning. That's going to be, actually I'm doing this in letters and not numbers. So this is going to be that $50 times 1 plus 0.06 over 12. And then how many times am I going to be adding this interest? Well, every single time I see a tick up here. So every time I see a tick, I'm doing that again. So that means that I'm going to be compounding interest on this thing 24 times. So this right here is the amount that that first $50 is going to be worth at the end of 2 years. Okay, so like that's 50 times 1 plus 0.06 over 12, because that 6% is being distributed over the course of a year, and we're compounding 12 times over the year. And then how many times is this compounding happening? 24 times. So I'm going to call this A sub 24. And that first $50, that's how much it's worth. Now, let's say, what about this $50? I know that I am redepositing $50 here. So then how much will that $50 be worth at the end of this 2 years? So that $50 is actually only going to get compounded 23 times. It's missing that compounding from that first period. So this $50 will be worth 1 plus 0.06 over 12 to the power of 23. And this is the amount that the second $50 will be worth at the end of 2 years. Okay, so if I were to keep going, we can see that the $50 that would be deposited right here would only be compounded 22 times. The $50 deposited right here would only be compounded 21 times. So each amount of money that we're putting in is earning less and less interest. That interest is being compounded fewer times. So until the very last $50 that we deposit. So this last $50 right here will be compounded one time. So that actually brings us down to what we're going to call A. And actually, I'm going to do A sub 2 as well, just so that we can kind of see this. So A sub 2 would be the $50 right here. And it's going to get compounded 2 times. So my A sub 2 then would just be 50 times 1 plus 0.06 over 12 to the power of 2. And then my last money, it's only going to get compounded that one time. So that's A sub 1, and that's just 50 times 1 plus 0.06 over 12. So this is the amount that my final deposit is worth at the end. Okay, so then what are we doing with all of these things? If I think about it, that first $50, all the money that I earn on that, it's now in the account. That second $50, all the money that I earn on that is added to that first $50. Then the third $50, all of the money plus all the money I earn on that is added to the original two. So what I'm actually doing, the amount of my annuity is actually going to be the sum of these things. So amount of in the annuity, or rather we'll call it the value of annuity. Value of annuity at the end of the time period is going to be, we're going to call it A. So we're going to say that A is actually going to be equal to A1 plus A2 plus A23 plus A24. And when we look at this, this is equal to 50 times 1 plus 0.06 over 12 plus 50 times 1 plus 0.06 over 12 squared plus 50 times 1 plus 0.06 over 12 cubed plus 50 times 1 plus 0.06 over 12 to the 24th for our final thing. Now, this is a sum. It's a finite sum. It's not an infinite sum like the sums we've been looking at lately, but it's still a sum. What kind of series is it? It's a sum, so it's a series. What are we doing to get from one term to the next? My first term here is 50 times 1 plus 0.06 over 12. To get to the next term, I now have 50 times 1 plus 0.06 over 12 squared. So to get from one term to the next, I'm just multiplying by 1 plus 0.06 over 12. Well, what kind of series is it when we're just multiplying by a number to get from one term to the next? Take a second, think about it. You know the answer to this. And hopefully you're now saying geometric series. This is a geometric series. And now that I know that this is a geometric series, I can write it using my sigma notation. So in other words, A is equal to the sum of n is equal to 1 to infinity. My first term, so that's 50 times 1 plus 0.06 over 12 times R, 1 plus 0.06 over 12 to the power of n minus 1. So here I just plugged in to my formula for a geometric series. Okay, I went up to infinity though. I should not have gone to infinity because this is a finite series. Where am I ending? I'm ending at 24. Okay, so it's all fine and good that we have recognized this as a geometric series, but how is that helpful for us? It's helpful for us because we know the general term for the sequence of partial sums of a geometric series. We know that that general term is S sub n is equal to A times 1 minus R to the n divided by 1 minus R. But remember, the general term for the sequence of partial sums, this S sub n is saying just add up the first n terms. Okay, well, that's what we're doing here. We're just adding up the first 24 terms of this geometric series. So A is actually equal to S sub 24. So in other words, I can go back up here and say that this is equal to S sub 24, which means that I will actually be able to calculate this thing. So now that I've thought of this as a geometric series, first of all, let's figure out what 1 plus 0.06 over 12 is. 0.06 over 12 is equal to 1.005. So now my A, which is equal to S sub 24, is equal to n equals 1 to 24. I'm only going up to the 24th term, so it's S sub 24, 50 times 1.005 times 1.005 to the n minus 1. But now that I can think of this as a geometric series, I know what my A is. My A is the first term. My A here is 5 times 1.005, except that I wrote 5 when I should have written 50. 50 times 1.005. My R is the thing that we saw that we're multiplying by to get from one term to the next. So this is equal to A, that's 50 times 1.005 times 1 minus R, 1.005 to the n. Well, my n is that 24. It's the same n that I defined earlier, all divided by 1 minus 1.005. Okay, so now this value really doesn't make sense in terms of money, so we're going to have to actually take this thing and plug it into our calculators. This is actually a pretty difficult thing to plug into a calculator, so you should go right now and make sure that you're capable of doing it and getting the same thing that I get here. It's also going to be important to remember that this is money. So if it's money, what that means is we only need 2 decimal places, and decimals are totally okay. And you know that normally they're not. So this is going to be equal to $1,277.96. So in other words, the value of the annuity at the end of 2 years at the end of 2 years will be $1,277.96. More than that, though, from this, we can come up with a general formula using the variables that we defined to start with. So in other words, my general formula here, and this is what's going to be the most important, my general formula is that A is equal to S sub n, and remember we defined n to be MT, the number of compoundings in total, which is equal to the sum of n equals 1 to, I'm going to write it as MT up here, so 1 to whatever that value is, P times 1 plus I over M times 1 plus I over M to the n minus 1 is equal to P times 1 plus I over M times 1 minus 1 plus I over M to the power of MT, all divided by 1 minus 1 plus I over M. Another way we could think about this is in terms of the general term of the sequence of partial sums, kind of like we just did here. So we could say that our A is equal to P times 1 plus I over M, and our R is equal to 1 plus I over M. So we calculate those things and we get that this is then A times 1 minus R to the power of MT, all divided by 1 minus R, where we've defined our A and our R off to the side. So this is our general formula that we are using to calculate annuities. Now, hopefully you were able to follow that a little bit. Let's actually take a second to go back to the previous problem. $1,277.96. How much did we actually gain in interest from that? So this isn't a problem that I'm really going to be expecting you to do, but it is sometimes interesting to think about. So how many times did I deposit $50? I ended up depositing $50 24 times, right? So if I deposited $50 24 times, how much money did I put into the thing? Well, I put in $50 times the 24 times that I deposited it, which gives me a total value of 1,200, which means that I actually put 1,200 of my own money into that, which means that that 6% interest really didn't get me far. It means that I actually only gained $77.96 over the course of 2 years. Anyway, hopefully this was helpful. Hopefully you understand a little bit, and see you guys later. Bye.